Hi there, and welcome to section 4. Now it's time to move further. In this section, we'll initiate, receive, and establish our first WebRTC session. In this video, we are going to learn about HTML5 and JavaScript. In the end, we'll also see some parts of the code, where the media is asked for and the signaling room is created. In the previous section, we followed codelab example from Bitbucket's repository. It's the official WebRTC example from official Bitbucket repository. You can access repository from bitbucket.org/webrtc/codelab. We are following step 7, in which we have code for video and audio exchange, signaling, and even data channels. Not explained during this introductory course, but they are another tool of WebRTC. We'll introduce data channels by the end of this section. We already checked that for having a web app working on Chrome, we need to server it. Local files have limitations. Node.js will help us to launch a very simple server. Besides, on this server, we want to establish a WebSocket between two peers, a channel where the signaling can take place. Socket.io is a great solution for that. Socket.io is a JavaScript library for real-time web applications. It enables real-time, bidirectional communication between web clients and server. It has two parts: a client-side library that runs in the browser, and a server-side library for Node.js. Let's understand server.js code and Socket.io methods. If we open server.js in our code editor, we can conclude that it's not a long code, but it's quite powerful. It's helping us to run a web server. Just calling the HTTP library method createServer. After that, if we visit on our browser our local IP, followed by this port, which is 2013, it will be reachable. That we already saw. If we go to browser and type http your IP:2013, we can access our server. By the other hand, let's see what's going on with Socket.io. So we created the app object, passed it to our Socket.io, and created a new object called IO. Basically, the IO variable listens to events for a certain server, our app. On each socket, some events have to be handled through callbacks, like in this case. If there is a message, this anonymous callback function is going to be called. In the same way, if there is an event called join, this anonymous function is going to be called. Log function. It's just for the debugging, logging the arguments of the connection, and it also sends the log back to the client side, which means in our browser. Message callback. It's used for when we receive a message from one peer, we'll send it to the other peer. This sounds like signaling, doesn't it? Finally, with the create or join event, we'll create the room if it doesn't have any participants, or we'll join if there's another peer. Notice that all these bindings are established once the socket got connected, and not before that, as expected. Let's see now the main JavaScript code, containing the truly WebRTC code. This code is served from JavaScript file, which is inside JS folder file called main.js. First, we have some constraints for the WebRTC server. We have the constraints for ICE servers, we have the PC constraints, and we also have the constraints for SDP. We want our peer connection to use data channels for chat, to use DTLS, and we want our SDP to force audio and video. That's why we have mentioned offer to receive audio and offer to receive video both as true. Then we see that here the socket object is created. We create, or join, our room by sending an event through the socket. The answer will be listened as well with these events. I think it wasn't so difficult, and Socket.io lines are actually recreating our signaling server. So if there's a message called created, this callback function will get executed. If there is a message called full, this callback will get executed. If we take a look on how we get our media, we can observe that two callbacks are sent: handle user media for success and handle user media error. The first one is the success callback, and the second one is the error callback. If success, handleUserMedia function will be called, and will attach the media stream to our local video stream. Besides, at this point, maybe start will be called if the current peer is the room creator, but the call won't be done until two peers are inside, which is indicated by the variable isChannelReady, set to true when the other peer joins. Maybe start will be called again once we know that the other peer has reached its user media. Then, the peer connection is created by calling the function createPeerConnection, and the negotiation begins. But we have that part for the next video. Please be patient. The end is near, and you're almost at your goal. In this video, we introduced the example that we are going to follow, the two JavaScript tools in which it's based, and we examined the code parts related to signaling and to get the user media. In the next video, we'll dive into the ICE candidates, exchange, and the SDP negotiation, studying the rest of the code needed for running this example.